EKC 326, what you see out there. So Chris, that there I heard from my friend Patrick Clarity that that's going to be obsolete. Is that
That is,
coming
yep,
back? Yeah.
that's correct. That's the EKC through 26 was an option we had around for a long time, and it was
20 years.
yeah, and it was part of an older system architecture, I'll call it, where we had individual components for each part of the system. So we had one device that was doing compressor and maybe gas cooler fan control, and you had another device like the 326 that was handling the high pressure valve and the flash gas bypass valve. And at just the evolution of our controls, we've moved to a setup, we call it a pack controller, a bit of a European term, but it's essentially one device that's now handling all the functions in a booster, transcritical booster rack on a CO₂ system.
So what is the options right now? So if just say an EKC 326 fails, what are the options? Because I know you guys have multiple options for these pack controllers. Just say they got all the setup and they have this controller, but this controller fails. What would be the best option? Because you're not going to change the whole rack controller at that point. How can they get those two valves up and running, the high pressure valve or the flash gas bypass valve?
Yep. So I actually have one here. I'll show it on screen if you want to see it. But this is a 782 model, but our other pack controllers use the same hardware. The 772A pack controller model is the one that we typically recommend as a replacement. And so there's some setup involved. So I mean, it is a little bit of programming through a computer. We have a piece of software called Service Tool. So you would want to connect in through that, but we have a document that kind of lays out wire for wire where you would move wires from the EKC over to the 772, and then some of the programming that's involved. So I'll show a slide here in a little bit that kind of one for ones the parameters that are relevant between the two devices.
And the service tool for nowadays on any supermarket rack, you need a computer or a computer from your office to log into it. Doesn't matter whose controllers is it. Can you use that service tool on the EKC 326?
No, that was you can kind of get a good depiction of it here on this first slide, but that's a model that had a few buttons and a display built right into it. So most guys were doing things right there at the device, not through a PC there.
Yeah, because once again, it's like a 20-year-old legacy product.
Exactly. Yeah, and you know as well as I do, it was probably a little less of a common thing to see guys with computers out there.
Yeah, no, 100%.
Working on systems. But yeah, so I've got some slides here as talking points, and the first one I've got is just kind of a kickoff to say when we say the high pressure side of the system, or what we talk about with what the 326 could do, it wasn't the whole system. So it wasn't the compressors or the gas cooler fans or anything down at the case level. The 326 was very specific to two parts of the system. It was the high pressure valve coming out of the gas cooler here that got depicted on the left side of this system drawing. And then a typical booster system would also have what we call a flash gas bypass valve coming off the receiver to maintain proper pressure there and dump some of that vapor out of the receiver original designs back into the suction line. And maybe there's some other things today that have evolved, but to bypass that vapor out of the receiver. So most of your audience probably has a good understanding of that at this point, but just so we're all on the same page, that's the parts of the system that the EKC 326 was meant to take control of.
Okay, and that's a big thing because I have a lot of people asking me is like, well, how does a controller really work? And especially because you get nowadays, you'll have your transcritical zone or mode, you'll have your transition mode, or you know, and you have your subcritical mode, and then you'll have, you know, your low pressure mode. And this is what's built in the algorithms of the controllers. And this is really what evolved over the years. Inside the 326A, did it have those algorithms built in already?
Yep. Yeah, and that's kind of what you see on the slide to the right here is the guys may think that there's one setting for the gas cooler pressure, and it was more of an efficiency strategy that we look at where we don't always want to shoot for the same pressure coming out of the gas cooler at any point in time. And that's where the sensors also become very important. So there's always going to be in this setup a temperature sensor that's at the outlet of the gas cooler. And we always stress the importance of that sensor being very close to the outlet of the gas cooler, within a few feet. We don't want to see it. Maybe if the gas cooler is up on the roof and the rack's down in a compressor room, we don't want to see that temperature sensor down in the compressor room. We want to see it as close to the outlet of the gas cooler as possible to really pick up the true temperature there, and
Yep.
insulated. We don't want any effects from ambient, but we take these values, and based on what that temperature is, we define in the controller what the optimal pressure is, right here also at the outlet of the gas cooler for the transducer that we would have. And by trying to figure out what that optimal point is, that's going to be what drives the opening degree of the high pressure valve. And so you get kind of 3 refrigeration cycles that you can see in the slides here, where we've defined at a specific temperature out of the gas cooler, which would be this pinkish line that you see highlighted in the middle of the 3 refrigeration cycles. We've picked 3 different points on our pressure, which would be the pressure at the outlet of the gas cooler, and that's the top part of each refrigeration cycle. And so depending on how high you allow that pressure to build up in the gas cooler, you can either allow it to build up at a lower level, but you don't get as much liquid back into the system for your cases. You can allow it to build up to a very high level here, but then you have compression ratio and other things to come into play. So yes, you get more liquid back into the system as an end result, but it takes a little more work to get there. And then you have really what would be defined as an optimal setup, where maybe it's not the maximum amount of liquid that you can get, but your compressors don't have to do as much work to get to where they are. So our controller tries to find that optimal point based on COP, and based on the temperature that we have out of the gas cooler, we'll pick a specific pressure target for that high pressure valve and try to get there.
Okay. And so this is only when it's in transcritical mode, it is acting like this.
That's correct. That's a very good point. Yep. Subcritical mode, we're operating almost like a standard HSC system, where we try to get a few degrees of subcooling out of the system. But yeah, we're not, because we're in the supercritical range there, we've got no condensing happening per se. So we have to treat things a little differently, and that's where the COP comes into play. When we're subcritical, we're operating this valve just to try to get a few degrees of subcooling out of it.
Yeah. And so when it tells it, the controller knows it's in transcritical through the pressure probe at the outlet of the gas cooler, as well as that temperature probe. Is that correct? So when they're above a certain threshold,
Yep.
we know it at 87.8 degrees Fahrenheit, 31 degrees Celsius, is that when we're above that, that's the critical point. We're in transcritical mode. So the controller is looking at those the two pressures and temperatures, or the pressure and the temperature. And when it is above that, it's like, I know I'm in transcritical mode. Now my algorithm is going to try to maintain the best COP.
That's correct.
Okay.
That's exactly right. Yep.
And at this point, because I know on some manufacturers, they'll have an ambient probe as well. On this one here, it doesn't take that ambient probe in consideration, like on your other controllers, like your pack controller.
Yeah, and the pack controllers aren't there. They aren't using that ambient temperature as part of the strategy for how these 2 valves would operate necessarily. That
Okay.
ambient probe really comes into play with the gas cooler fans and how they would be controlled.